2 years ago, we talked about the introduction of 45 nanometer technology. And today we're going to talk a lot about 32 nanometer technology. And our TikTok strategy is to introduce a new microarchitecture design every other year and to introduce a new process technology every other year. And 32 nanometer is alive and well, and we're going to show you some of those products today. But first, let's talk a little bit about the transistors themselves. If you can go to the next slide. Apologize for showing you a technical chart, but there are those who said that with Moore's law, while we can continue to create more transistors, that it will be increasingly challenging to make those transistors better and faster. And with 32 nanometer, we've actually been able to continue to build a much better transistor, not just a smaller one. And this is some technical data that we've published. And to understand this, on the y-axis, you can see what's called I off. That's the leakage current of the transistor. So how much electricity is wasted when the transistors are turned off. And then on the x-axis, you can see the drive current of the transistor, or how much current it can drive when it's turned on. And so the ability of a transistor to turn on to a strong current we associate with performance, and the ability of it to consume very little power when turned off we associate with energy efficiency. And as you can see, our 45 nanometer product compared to the 32 nanometer, at the same leakage current, or at the same energy efficiency, we're actually delivering 14% performance increase for our N devices and 22% for our P-type devices. And similarly, if we took at the same point in the curve, we said, hey, let's keep the performance the same, but let's try to see how much current we could save. You see the leakage current goes down by a factor of 5 for the N device, and a factor of 10 for the P device. So we have succeeded based on 2 years of high volume manufacturing experience with high K metal gate technology at 45 nanometer. We've been able to use that experience to deliver a next generation version of high K metal gate that delivers superior performance. So, but that performance doesn't mean much unless we can bring it into high volume manufacturing. And we are well on track to bring 32 nanometer into high volume. Some of you have probably seen us present this chart on previous generation processes, and what this shows is our progress towards reducing defect density. And as we move down this curve, we associate that with higher and higher chip yield. And so you can see over the various generations, we were able to achieve a very low defect density and a high yield, and in fact, on 45 nanometer, we've gotten to some extraordinarily impressive defect density rates. And then today, with 32 nanometer, we've actually been able to reduce it considerably over time, and where you can see as those curves are very parallel, that we're very much on track for high volume production later this year. Great transistors are one thing, but what we're going to do with them, I think, is what most people are interested in. We released a product in November called the Core i7. Many of you remember that. This is our Nehalem architecture, part of our TikTok model. That was our talk on 45 nanometer and new architecture with 8 threads of performance, the turbo boost technology. It's an extraordinary product and delivers a lot of performance. But today it's really for the high end. It's for the enthusiast. It's a relatively expensive technology, but what we want to do is bring the Nehalem architecture into mainstream computing, and that is a major project for Intel over the next several months. We'll begin actually even before 32 nanometer with some products called Linfield and Clarksfield. I apologize for the alphabet soup of code names, but Linfield is our desktop quad-core product that fits on a more mainstream platform, and Clarksfield similarly is a mobile version as well. And by the end of this year, we'll be in production on dual-core quad-thread versions, both for desktop and mobile. That's Clarkdale and Arendale. And those products also include integrated graphics on the CPU. Those two products, based on 32 nanometer technology, allow us to really bring the Nehalem architecture through our mainstream product segments and really bring the value of that Nehalem architecture that we launched in November to a much greater number of people, thanks to 32 nanometer technology. So Just to show you that we're actually on track, I'd like to share with you first the desktop system here. This is a Clarkdale 32 nanometer processor. We've just got a few things running here. There's a video running on the graphics engine. You can see the 4 threads in operation. And then we've got a Black-Scholes option pricing algorithm here that I think 32 nanometer technology is necessary to keep up with the losses on Wall Street at this point, so it's important for us to keep up. And then over here on the left, you can see we actually have a notebook running on 32 nanometer as well. And this is the first time we've been able to bring the Halem architecture into a mainstream notebook type category. So certainly mobility, fastest growing market segment. We're very excited to bring the Halem architecture to that.